Aloha and welcome. In this video, we're going to be discussing authentication protocols, specifically the Radius and TACACS Plus protocols. So let's go ahead and open up our textbooks. So here we see we're in section 2.8, Authentication Protocols, Radius and TACACS Plus. We start off with Radius. So Radius is the remote authentication dial-in user service, Radius. I remember this from a long time ago when we actually had physical dial-up and we would use Radius. It's no longer just for dial-up anymore, even though dial-in is in the name. But this is a networking protocol that's going to allow for centralized authentication, authorization, and accounting. AAA, we call it, AAA services. So the Radius protocol, it's going to combine authentication and authorization services. So this is different from TACACS. TACACS keeps those separately, but the Radius protocol is going to combine authentication and authorization. So Radius is going to use UDP port 1812 for authentication and authorization, and it's going to use the UDP port 1813 for the accounting. The accounting is just the logging, keeping a list of what everybody has done for, looking at later. So you can see here, for example, Windows Server 2019 can be configured to use the Radius protocol for authenticating and authorizing users. So one thing that I want to point out here, we're talking about UDP ports, and the difference between Radius and TACACS is TACACS uses TCP 49, I believe, TCP port 49. So I told you in the last video about how a computer has a bunch of virtual ports on it, and we talk about which port that they're using. There's two different types of ports. There's UDP and TCP, and really there's the main thing I want you to think of when you're thinking about TCP and UDP. TCP is it's a transport control protocol that it uses a handshake, and it's secure. It makes sure that there's a control so that, let's say, when you're taking information and you're sending it, let's say you go to a website and you go out, your client goes and says, "Hey, send me some information," and it pulls that information from the server. There's a conversation that happens there, and all of the data that gets sent back to you, it's not just one big boom, here's your web page. What's happening is your request is sent in a little tiny message that goes out, and those messages are broken up into what we call packets. Packets are these pieces of information that usually have a certain amount of data in it, and you send out these packets, and then the website receives it and says, "Okay, I'm going to give you all the information on this page, and this page is going to be 1,000 packets worth of information." So it goes ahead and it creates these packets. The packets are going to have information like where it's going, and it'll have like a correction thing in there in case it arrives and it finds out that it lacks integrity, it's actually damaged or corrupt or something. It'll realize that. And TCP, the protocol allows for the sequencing. So when you take that 1,000 packets of data and you're going to send it from the web server back to the user so they can look at it in a browser, TCP is the protocol that allows you to do that. It allows you to take those 1,000 packets and send it. So it's going to control the sequencing of those packets. It's going to make sure that they arrive in the right order. And if one doesn't arrive, it will request that it get resent. Or if it arrives corrupted, like we said with the integrity, it has that little integrity check on it so it can see if it's corrupt or not. So if it arrives corrupt, it can ask it, "Hey, send me a packet 222. That one was messed up." So it'll resend that, and then it'll take that and it'll reassemble it at the client at your computer, and it'll turn that into a web page for you. So TCP is what does all that. So UDP is kind of like TCP in a way, except that I think it's user datagram protocol is what it stands for. I may be wrong exactly. I'm just talking off the top of my head here, but UDP is a little bit different in that what it's doing is it's going out there. It's not doing any of these checks. It's not doing a lot of these checks for sequencing and things like that. And we use this in things that are more time sensitive. Let's say we're dealing with video streaming and stuff like that. It wouldn't make any sense, when one little packet is just a little tiny blip of, maybe audio or something else. It doesn't make sense to use TCP because TCP is going to take time and it's going to make sure, oh, that didn't arrive, go send it back to me. So you're going to have little hiccups and it's going to seem really weird. It's better just to, "Hey, we missed that. Don't worry about it." So UDP is used in situations where it's not as critical, where time is more critical than the actual sequencing of things and making sure that everything is sent properly. And TCP is used to make sure that everything is done sequenced properly and anything that's missing is included. So just think of those two differences. Um, I just want to explain that there is a difference and they use different sets of ports. So we're using Radius to begin with here, and Radius is going to use port 1812 for the authentication authorization. So anytime you've got anything dealing with the authentication and authorization, it's going to port 1812 UDP. Anytime you're dealing with the accounting, which is the logging, that's going to be on UDP port 1813. So again, the two different types of ports we'll be talking about, TCP, UDP. You'll need to know these numbers for Radius and TACACS. You'll probably have a question on the certification exam for, hey, which one uses port 1812? What is it used for? Things like that. So you'll need to understand that. And later on, we'll see TACACS Plus uses TCP 49. We'll talk about that then. So getting back here, the Radius protocol is used for exchanging messages between a Radius service and a Radius client. A Radius server provides authentication and authorization services. A Radius client is a network attached server, a network access server that acts as an intermediary for a connection request from a user to a Radius server. This should be sounding familiar to something we've just studied. So a network access server, NAS, also known as a remote access server, RAS, which is what I'm more familiar with, is an access gateway between an untrusted external network and an internal trusted network. Okay, so I want you to remember that. So this network access server, it's providing you access. It's a gateway between untrusted systems and trusted ones. Okay, so that's very important to keep in mind. So there's some terms here that drive me nuts. So we're talking about a Radius client. Usually when we think about clients, we're thinking about end users, but a Radius client in this case is really kind of a server in a way. And it's called a NAS, which is a network access server, even though it's a Radius client. So I hate the way they're changing these things around, but just remember that a Radius client is actually a Radius client. It's a network access server. And another thing that drives me nuts is they're using NAS here, NAS, Network Access Server. NAS, now typically when you talk about it, people think of network attached storage, like they have a little hard disk that's attached to the network that you can go to. So that's, whenever I hear NAS, that's what I think of, not Network Access Server. So in computer science, we reuse a lot of the same acronyms here and there. MAC addresses, MAC is one that gets reused a bit. So yeah, you just have to understand it from the context of what we're talking about. So let's go back in here and talk about it again. We've got a Radius client. A Radius client is a NAS. It's a network access server. So what happens is users out in the dirty, filthy internet or wherever, when they want to connect to our pristine network, they're going to have to go through this NAS. And this NAS, also known as a RAS, a remote access server. Remote access server is the better way to call it, I think, because you think about it, they're remotely accessing it. So I like that better. So I like RAS, but RAS or NAS, either one interchangeable here. They're the gateway through which you've got to go for a user, an unclean, dirty, filthy user to get into our pristine network. Okay. So that NAS or RAS is going to control that access. It's going to use this thing called Radius protocol to go out to the server. So our server, our remote access server, is the one that's going to be passing judgment and everything, and it's going to be looking at everything. So we see here in figure 2.8.1, this is the Radius protocol. So you have users out here. You also have wireless Windows users that are going to, or wireless users, sorry, that are going to connect to this wireless access point. So this wireless access point, all the people connecting to it, they're not trusted. So when we want to allow them in, they're going to have to go through this Radius client right here. So the NAS. So they'll connect to the NAS using the Radius protocol to the Radius server. So hopefully this makes sense. Go ahead and answer some questions here about it. Now we're going to talk about the Radius authentication. So A user that wants to authenticate to a network connects to a Radius client. We talked about that. Radius client then prompts the user for their credentials. Hey, give me your username and password. And then it's going to send this access request message to the Radius server. So that is up here in this. So it's going to send, the hey, give me your information. And it's going to take that and it's going to use Radius protocol to send it to the Radius server. Okay. So an access request message is an authorization request that contains the user's credentials. A Radius server validates the user's credentials using an authentication protocol such as CHAP. So the things that we've learned in the past for authentication protocols, it can use that within there to actually do it. So CHAP, if you remember, it used a hash and everything to make sure that they're the same on both sides. So go back and review that if you need to. So then the Radius server responds to an access request message with one of the following messages. It's going to reject it, it's going to challenge it, or it's going to accept it. So reject is going to be a message saying, hey, your credentials, they weren't valid, too bad. And then it's going to get cut off from the network. Then we've got the access challenge, and that's going to be used when you need more additional information. So if the Radius server wants to get like a secondary piece of information, like a PIN or a second password, something like that, it'll send an access challenge. And then after it's satisfied that this user is who they say they are, they're going to send an access accept. So the Radius server is going to send that to the Radius client if the user's credentials are valid. So if a user is successfully authenticated by the Radius server grants the user access to the user's authorized network resources. Okay, so we can see that in our participation activity here. So when we click on start, a user connects to the Radius client. So it's going to the Radius client here. The Radius, and this whole diagram looks kind of familiar to one we just worked with. So a user connects to the Radius client. The Radius client sends the user's credentials to the Radius server in an access request message. So the access request message is going from here, from the Radius client to the Radius server. The Radius server then sends an access reject message to the Radius client if the user's credentials are not valid. So if that happens, the Radius client disconnects. This Radius client is going to disconnect the user's connection. It's just going to chop it right off. So then the Radius server sends an access challenge message to the Radius client if the Radius server requires additional information from a user, such as the user's PIN. So they're going to try to connect, and once they try to connect, the Radius client sends the access request with the credentials in it. They're going to send back a challenge for more information, and that goes back to the user. Then we've got the Radius server sends an access accept message to the Radius client if the user's credentials are valid. The Radius client starts the user session. So you can have them try to connect. It'll go, the credentials go through the access request, come back as an accept, and then they go ahead and start the session for the client or for the user. Then the user sends a disconnect message to the Radius client. So the user over here is going to send a disconnect message to the Radius client. Or the Radius client stops the user's session at that point. All right, and then you can go ahead and check out your knowledge here. Go down into Radius protocol, do some checking. This is going to solidify some of your understanding of the technology as well. Then we get into TACACS Plus. And TACACS Plus is different from Radius. Radius is not proprietary, it's open standard. TACACS Plus is actually developed by Cisco, and it does the same. It's AAA services. It does the authentication, the authorization, and the accounting. It does not combine the authentication and authorization, though. It separates the two out. And TACACS can be used to authenticate both a user or a device. So it can do a device and not just a user. So TACACS, as I mentioned before, it's using TCP port 49. That's one of those things put in your memorize list. So you've got 1812 and 1813 UDP for Radius. Remember that, you've got the first two. Your accounting is done on 1813, and the authorization and authentication is done on 1812. Over here, TACACS does everything on port 49. So unlike Radius, that only encrypts. So Radius is only encrypting the password. TACACS is actually, it's going to encrypt the entire packet. So when I talked about when you're sending data between, data on the network, it breaks up into these little units called packets. So TACACS Plus it encrypts the entire content of each packet when it's sending it back and forth. Radius is only it's only encrypting the password, so that's something you may need to remember as well. That's one of those little things that differentiates the two. So you might see something like that on the certification exam. So TACACS Plus client is a network access node, such as a network access server. So just like the terminology we use for Radius, TACACS Plus client is going to be kind of the server. Then the TACACS Plus server contains authentication information for users and devices. So NAS obtains a user device's credentials and sends an authentication request to a TACACS Plus server. A TACACS Plus server responds with one of the following messages. It's going to accept it, it's going to reject it, or it's going to give an error if something happened during due to a network error. So let's read that just real quick. So you've got TACACS client. The TACACS client is a network access node, such as a network access server, and that TACACS Plus server contains the authentication information for users and devices. So we're doing users and devices, whereas Radius was, I believe, only the users. So a NAS obtains a user or device's credential and sends the authentication request to the TACACS server, okay? So it's going to send it to the TACACS server, and then the TACACS server is going to respond either accepting, rejecting it, or if there was an error in the process, it will send an error message. So TACACS Plus, what is the difference really between TACACS Plus and Radius in terms of when to use it? Well, here it talks about how TACACS Plus is commonly used for authenticating an administrator account to a network device such as a switch or router. So when you're authenticating an administrator to do work on devices, that's usually when you're using TACACS Plus. So here we have a comparison chart between Radius and TACACS Plus. So functionality, Radius is going to be combining authentication and authorization, whereas TACACS Plus separates them. So that's one thing to keep in mind. Remember that Radius is open standard, whereas TACACS Plus is proprietary. It belongs to Cisco. The primary usage, Radius, you're going to be doing network access, and then TACACS Plus is mainly going to be used for device administration. Security, Radius does encryption of passwords only, and TACACS Plus does encryption of all AAA packets. Multi-factor authentication is not supported on Radius, but it is supported on TACACS Plus. And then again, the protocols, we're using UDP on Radius, we're using TCP on TACACS Plus, and we're using 1812 for authentication and authorization, and UDP 1813 for accounting. Over here on the TCP side, we're using 49 for everything, TCP for everything with TACACS Plus. And then we'll have some exercises for you to do down here to understand. And it's really good because it gets into some to really probe it if you understand the differences between Radius and TACACS Plus. So this is a good section to work on here. So that's it for our section on Radius and TACACS Plus. If you have any questions about this, reach out to me. I understand there's some network ideas here that may be a little bit foreign to you. If it is, just reach out. I'm happy to work with you on that. Okay, so other than that, I will see you in our next lesson.